All right, so in this lesson, we are going to solve a system of equations, linear equations, by using the elimination method. So using the elimination method. So once again, we are trying to find the x and y that makes this equation true and makes that equation true. So I'm just going to show you how to do it first, and then we will talk about it, I guess, as we go. So we have x minus y equals 11 and 2x plus y equals 19. So I'm just going to stack these on top of each other. X minus y equals 11 and 2x plus y equals 19. Now, it is called elimination because our goal is to eliminate either the x's or the y's. Now, if we put the x and 2x together, we get 3x. If we put the negative x and x together, they're eliminated. Like negative x plus x is 0 x's. And of course, if we put 11 and 19 together, we get 30. So our goal is to be able to cross out this one or this one. In this case, if we combine these equations, I want you to think about it like that. If you combine these equations, then these will go away. So I'm not going to write it like that, though. I'm just going to write it like this, and then I'm going to write 3x from x plus 2x is 3x. And then now we have 11 and 19. So I want you to think about it like this. It's useful to think about it like this. We took the equations, we put them together, something went away. Like one of the y's went away. And then we just divide by 3. And we get x equals 10. Now here's the thing, that the solution has an x and a y. So we got to plug 10 into here or 10 into here to find it. I'm going to do it for both just to show you, but you'll only have to do it for one. So x is 10. So I'm going to do x minus y equals 11. And then I'm going to put 10 minus y equals 11. And I will subtract the 10 from both sides. Negative y equals negative 1. 11 minus 10 is positive 1. And then I'm going to divide by negative 1. And my y is negative 1. Now, this should be the same for both. So I'm going to plug in the x. Remember how x was 10? I'm going to plug it into this one and see if I get the same answer. So when x is 10, so 2x plus y equals 19. So if x is 10, so 2 times 10 plus y equals 19. 2 times 10 is 20. And we subtract 20 from both sides. And you get y equals 19 minus 20 is negative 1. So after you find out what x is, it doesn't matter which equation you plug it into, you'll get the same answer. Because remember, we're finding the x and the y that make each of these true. So if x is 10 in this equation, then y has to be negative 1 for the left side to be equal to the right side. If that's supposed to be true for this one too, then if I plug in 10 and I find y, I should get the same y, because that's the whole point. And let's go ahead and write our statements. So the solution to this system of equations is 10 comma negative 1. This means 10 comma negative 1 this means 10 negative 1 makes both equations true. Visually, both lines will intersect at this point. Remember that we have a bunch of xy's here that make 11, and we have, here's an equation. If we graph it, the solutions to this equation, we'll have a line. And if we graph the solutions to this equation, we'll have a line. And they share 10, negative 1. Both of these lines share 10, negative 1. So just like yesterday's lesson, or the last lesson we did, the lines or the solutions will intersect. The solutions will intersect at 10, comma, negative 1. All right, let's go to the next one. All right, example number 2 reads negative 6x plus 5y equals 1 and 3x plus 2y equals negative 5. Now I'm going to stack these on top of each other. My goal will be to eliminate either the x's or the y's. 3x plus 2y equals negative 5. Now, if you put these together, negative 6x and 3x, you don't get 0. So we can't cross those out. If you put 5y and 2 together, you get, and 2y, you get 7y. So you can't cross those out, right? We can't cross either the x's or the y's out. So what we do is we change this, or we change one of the equations. We change one of the equations. So for instance, I know that if I multiply this equation by 2, I get positive 6x plus 4y. So remember, 2 times 3x, 2 times 2y is 4y. And then I'll have to go like this also. And 2 times negative 5 is negative 10. So this equation, as long as I do it to both sides, as long as I do the same operation to both sides, the x and y's will stay the same. And then I will rewrite this one down here. Negative 6x plus 5y equals 1. So now I can cross some stuff out. So 6x minus 6x is 0x. 4y plus 5y is 9y. Negative 10 plus 1, or 1 minus 10 is negative 9. And then I divide by 9. Make that a little more 9-ish. And then I get y equals negative 1. All right, so I got my y. So once again, it doesn't matter which one I put it into. I will get the same answer because I'm supposed to get the same answer if I did this right at least. So I like this one because, I don't know, this one has negative in front. This one seems fine. So we have 3x plus 2y, equals negative 5. And this time for y, since I found y, and this one I found x, so I substituted, like x was 10, so I put x in, I made x into 10. I substituted in 10 for x. Right there, and I showed you right there. This time I found the y is negative 1, so the y will be negative 1. So 3x plus 2 times negative 1 will equal negative 5. All right. 2 times negative 1, a positive times a negative is a negative. So 3x minus 2 equals negative 5 plus 2 plus 2. 3x equals 2 minus 5 is negative 3. Oh, that's handy. So we divide by 3. And x equals negative 3. Negative divided by positive is a negative 1. So, what a coincidence. Negative 1, negative 1, see? All right, so my solution to my system is negative 1, comma, negative 1. Nice. Remember that as soon as I figured out that y was negative 1, I had the choice of substituting in negative 1 for y in this equation or this equation. I just chose this one because I liked that it said plus and this one wasn't a negative. But you could have put it in here and you would have gotten the same answer, which is x is negative 1. All right, so let's see what to do here. So negative 4, I'll allow a little more room. Negative 4x minus 2y equals 14, and 10y plus 10x. 10x plus 7y equals negative 25. All right, so 4 times something can't give me 10. 2 times something can't give me 7. So I can do a couple of things. I want to find a common multiple, right? A common multiple of 10 and 4, or a common multiple of 2 and 7. I like 4 and 10 a little better. 4 and 10 both go into 20. 4 and 10 both go into 20. So I'm going to multiply this equation by 5 so I can get negative 20. And I'm going to multiply this equation by 2 so I can get positive 20x. So 5 times negative 4 is negative 20x. 5 positive times a negative is a negative. 5 times 2 is 10y. And then, I can do that tiny bit better. And 5 a positive times a positive is a positive. 5 times 10 is 50. 5 times 4 is 20, so I get 70. All right, let's do this one. 2 times 10x is 20x. That's what I wanted it to be, so I can cross it out later. A positive times a positive is a positive 14y. And a positive times a negative is a negative 50. All right, so negative 20x and 20x together will give me 0 x's. And negative 10y plus 14y, so that's 14 minus 10 is 4y. I can do better than that. And 70 minus 50, or negative 50 plus 70, gives me positive 20. And I divide by 4. And I get y equals 5. Ooh, I don't know why I can't do that. Okay, y equals 5. It doesn't matter which equation I put this y in for, I will get the same x. So I like this one. So 10x plus 7y. 10x plus 7y equals negative 25. And for y, I'm going to substitute in 5. So we get 10x plus 7 times 5 equals negative 25. And a positive times a positive is a positive, so I get 10x plus 35 equals negative 25. And I look like I'm going to need a little more room. So minus 35 minus 35. I get 10x equals negative 25 minus 35 is negative 60. I divide by 10, and I get x equals negative divided by positive is a negative 6. Remember that my solution goes in the form of x comma y. Oh, I was about to put that x comma y, right? So it is negative 6 comma positive 5. Remember that this negative 6 positive 5 will make this equation true, and it will make this equation true. So that is it. Thank you.